What we're going to do is we're going to graph linear inequalities. And I knew that you could handle this lesson this way because we're going to do anything different as far as graphing lines. We're looking for y equals mx plus b. So I have plus 5 as the y-intercept. So we find plus 5 on the y-axis. And we're going to use the slope of negative 2. So down 2 and over 1. Remember, we use that over 1. Now here's where the only differences are. If we had, when we're graphing on the number line, solid circles, right, that means it had the equals to, then we would actually go ahead and fill that in. The equivalent to that, when we're talking about our lines, is a solid line. So I would make this a solid line because it is the equal to. So we're reading all those parts basically from right to left when we have y equals, taking care of that. Last thing we want to do is I need to test out a point to find out I need to shade one side or the other. So I'm going to decide what side is going to be true. So the easiest point in the whole wide world is going to be the origin, 0, 0. So we're going to plug in 0, 0. So 0 is greater than or equal to negative 2 times 0 plus 5. The nice thing about using 0, 0, this will always clean up real nice. So 0 is greater than or equal to 5. Well, is that true or false? 0 is greater than or equal to 5. That's false. Okay, that means that this point is false. So if this point is false, the entire bottom side of this line is false. So what we're going to do is shade the opposite side. That must be 2. Alright, next thing we're going to do, same idea. Next problem. So again, we're starting with y equals 4. Y-intercept of 4. Here we go. I have a slope of 4, so we're going to go 1, 2, 3, 4, and run 1. I'm okay with that. We're going to study our inequality. Y is less than but not equal to. Less than but not equal to. Dashed line, right? That would be an open circle on the number line. Okay, you guys remember what I'm talking about as far as the number line? And we would have open circles and we would have closed circles. Right? Closed had the equals to. So that would be equivalent to our first line. Open circles equivalent to our dashed line. Now the last step that we have is we're going to test out the easiest point on here, 0, 0, as long as it doesn't go through it. So we're saying 0 is less than 4 times 0 plus 4. 0 is less than 0 plus 4 is 4. 0 is less than 4. That's true. 0 is less than 4. So if this point is true, that means everything on this side is true. Okay. So instead of just having points on a line, now we're going to have an entire one side of the coordinate plane. First up, we're all going to start with y equals, so that's not too bad, or y greater than, less than, that type of thing. And then eventually we have to do a little bit of extra work. So again, number 3, now we get to that extra step. We have y is greater than negative 4/5 x plus 0. So we're going to start at the origin, 0, 0. We're going to use negative 4/5. So we're going to go down 1, 2, 3, 4, and out 5. The next thing, so we've started with a y-intercept. We've gone to our slope. Keep working left. Y is going to be greater than that. Okay, solid or dashed? Well, it only has greater, not greater than or equal to. So I have a dashed line. Alright. Next step, I cannot test 0, 0. That's on the line. That doesn't help me decide one side or the other. So what I have to do is pick something else. So maybe I'm going to pick the next easiest thing that I think is 1, 1. So I'm testing the point at 1, 1, which means 1 goes in for y and 1 goes in for x. We're trying to see if this inequality is true or false. So 1 is greater than negative 4/5, right? 1 times negative 4/5 is negative 4/5. 1 is greater, that's true. That means this point is true, which means everything on this side is true. So if it's true, we highlight that side or shade that side. Number 4. Again, it's already y by itself, so we're good to go here. Y-intercept of plus 1. Slope, negative 1 over 1, negative 1 over 1. We're looking at greater than or equal to. If I see that equal to, that means I'm talking about a solid line. And now we're going to test a point. I see that 0, 0 is available. It's not on the line. So I can say 0 is greater than or equal to negative 1 times 0 plus 1. As you do a bunch of these, probably by the back of this worksheet, you're going to say, I don't need this. So 0 is greater than or equal to 1. I don't think so. Okay, 0 is not greater than 1, so that's false, which means that this point is false, which means the other side is true. All right. I have to remember some of those little wrinkles of things that we thought of when we were dealing with our lines. So y is greater than 1. Well, it only has y, and it has y is 1. So I'm going to find where y is 1. And if you remember, that means that we're talking about a horizontal line. So the rest of it is that we don't have an equals to, so I need a dashed line through that horizontal. And if we say y is to be greater than 1, well, what side's greater than 1? 2 or 0? Well, 2 is greater. So this is a real simple one to shape. We're just going to go greater than. Okay. So horizontal line. All right, number 6. Here's a good one. You might want to pause right now and try this one, because now we finally got through a couple different examples. So go ahead and pause it and try it. All right. Now that you've unpaused it, here we go. Negative 5. Down 2 for us. So negative 5. All right, we're dealing with rise 3, run 7, or rise 7, run 3. So we went down 5, 6, 7, and run 3, 1, 2, 3. The next thing we look at is our inequality. It looks like it's going to be a dashed line. It does not include the equals to part. Next thing we're going to test is 0, 0. 0 is less than negative 5. 0 is less than negative 5. What do you think? Good. That's false. Okay, that's false. So that means the opposite side is true. All right. Hopefully you did well. We're going to move on to the back. We have a couple more examples. Again, these two, maybe you want to pause again and try this. So I'll give you a second to pause. 1 1,000. Very good. All right, plus 2. Plus 2. We're going down 2 and over 1. We have a dashed line because it does not have the equals to. And we're looking at 0, 0 is a good point we can check. So 0 is less than 2. 0 is less than 2. That's true. That's true. This side is true. Number 8, we're at plus 1. We're going to rise 1 and run 2. We do have a solid line this time. And we're going to test out our 0, 0 because it is not part of the line that we're testing. So 0 is greater than or equal to 1. 0 is greater than or equal to 1. Let me think about it. No. 0 is less than 1. So this is false. So this point is false. So we're saying the bottom side of the line is false. So what side must be true? Right? Just like true, false. If you got it wrong, it must have been the other one. So it was wrong on the bottom side of the line, so I have to use the top side as far as shading. All right, number 9. Here's where the rubber hits the road just a little bit, my friends. We need to get y by itself, so we have to remember a few things about solving. So I'm going to subtract 3x. I have negative y is greater than or equal to negative 3x plus 5. I'm going to treat that negative as if it was negative 1, and I'm going to divide that out. Y is, here's the key, less than or equal to. Remember, when we divide by a negative, I have to flip the inequality. So now it is positive 3x and minus 5. Once we're at this point, it's just like the rest of them. So we highlight, we definitely got that right away. As soon as I see this as a negative y, divide by a negative, I need to change the inequality. So if you have to write yourself a note here by number 9, divide by a negative, flip the inequality. All right, let's graph it. So we got minus 5 as a y-intercept. We're going to rise 3, 1, 2, 3, and run 1. I see less than or equal to, so that means we're going to be solid because it can be equal to. Very nice. The origin is open, 0, 0. Let's go to the one that we made, so it's nice and simple. So 0 is less than or equal to negative 5, right? We put 0 in for x, so that 0, 0 is less than or equal to negative 5. Absolutely not. It is false here. All right, so if it's false, that means the entire top side of the line is false. Let me get the highlighter so you can still see over here. All right, that means we're going to the opposite side. So origin was false, it must be the other side of the line. All right, here we go, number 10. So you see, these will take just a little bit more space because we need to solve for y. But I don't see a negative with the y, so I'm not going to flip the inequality. So I know when I get done, it's going to be y is less than. So we are going to subtract x. So now I have 2y is less than negative x minus 2. Then we're going to divide it by 2. All right, so we have y is less than negative 1/2 x and minus 1. So here's the equation I'm dealing with. We got negative 1 for a y-intercept. We have a slope of down 1 and over 2. I have a dashed line. Okay, so we put that somewhat over my work there, but that should be okay. Real nice here, the origin is open, so we're going to test it. 0 is less than negative 1. 0 cannot be less than a negative, so that's false. So that's false. Let me grab the highlighter. And if it's false on the top side of the line, there's only the other side that we could have. So it's true on the bottom side of the line. All right, 2 more. You're doing great, I hope. I'll find out tomorrow. All right, number 11. Oh my goodness, they gave you an easy one. After all the stuff we did, they gave you an easy one. Subtract 8x. Here we go. Y is greater than or equal to negative 8x plus 4. Oh my goodness, it couldn't be any easier than that. Plus 4. Here we go. Down 8 over 1. There we go. I see that it can be equal to. That means we count that line, which means it should be solid. Let's see if I can make those connect. That's pretty close. And I see that 0, 0 is available. 0 is greater than or equal to 4. Oh my goodness, it's false again. All right, so the origin is false, which means I need to go to the other side. The origin's on what looks to be the left side of the line, so I'm going to shade the right side because this inequality was false. Okay, so anything on this side would make that true. All right, now they really set us up. All right, last one. I see right here I have negative 3 with the y. That means I'm going to have to change out the inequality. All right, we're going to have to flip that around as we solve. So let's solve away, my friends. Subtract the x. I have negative 3y is less than negative x minus 9. We're going to divide by negative 3. Y, flip the inequality, greater than, negative divided by a negative, positive 1/3 x, negative divided by a negative, plus 3. All right, now what happened here is I got my work in the way just a little bit. So if it's all right with you, we're going to move that over just a hair so you can see what's going on. But now I can see the graph as well. Here we go. I get plus 3. There we go. There you are, plus 3. Thank you very much. We got 1/3. Rise 1, run 3. Here we go. So I took care of that. Check my inequality. Solid or dashed? I can't hear you. Maybe it's because it's a video. Either which way. All right, it should be dashed. All right, so there we go. Now we have check this out. So we're going to check that out. Let me change colors. Here we go. We get 0 is greater than 3. 0 greater than 3? No, that's false. So this is false. Let me grab the highlighter. Here we go. Highlight. If this side is false, right, this looks to be the bottom of the line. What must be true is the top of the line. Remember, you don't have to check things when we're talking about a true-false question. If you get it wrong, it's the other one. So we're saying that this was wrong, right? This was wrong. So the other side must be right. All right. Now focus in here. Here are all your answers. If you skipped anything. and you just want to get a general idea on did you have solid or dashed, and with your solid and dashed, did you shade the correct side? So a real simple check here.